Good evening, everyone. I am Eswar. My project title is Rock and Mine Detection. Objective of my project is to develop a system that have a capable of distinguishing between mines and rock beneath the submarine, as the enemy country has planted explosive mine in the ocean that detonate upon contact with an object. Furthermore, there is a possibility of encountering rocks in the underwater environment. Um, let's see about dataset description. My dataset is a secondary data. From Kaggle, I collected this dataset. My dataset dimension is 61 cross 208, that is 61 columns and 208 rows. I listed some related research papers that is related to my project. I listed 5 research papers. Among these papers, they achieved 92.8% as a maximum accuracy with this model, that is RDNN for classification and prediction of rock or mine in underwater acoustics. So our motto is to create a model which gives more accuracy than this. Let's see what work I have done in my project. Base model and accuracy obtained. I used the base model as support vector machine and gradient boosting classifier, light gradient boosting classifier. In that, I achieved 75% accuracy in support vector machine, 83.33% accuracy in gradient boosting classifier, and 85.71% in light boosting, light gradient boosting classifier. After that, I need to improve their accuracy. So I plan to implement hyperparameter tuning on this three base model techniques. First, I implemented hyperparameter tuning on SVM. I implemented up to 8 hyperparameter tuning on SVM, that is grid search, simulated annealing, Bayesian optimization, particle swarm optimization, and genetic research algorithm, and randomized search, tree structured Poisson estimator. After applying these hyperparameter tuning on SVM, I achieved 86% 0.53% at max, that is through grid search and simulated annealing. After that, I moved to light gradient boosting. In light gradient boosting, I have applied this much hyperparameter tuning algorithm, that is a tree structure Poisson estimator, genetic algorithms, a randomized search, simulated annealing, grid search, and Bayesian optimization. In tree structure Poisson estimator, I achieved 91.5% accuracy at max. After that, 90.5% accuracy in genetic algorithm, 90% accuracy in randomized search, 88.5% accuracy in simulated annealing, 83.33% on grid search, 80.95% on Bayesian optimization. So till now, I achieved only 91.5%. Our motto is to achieve more than 93%. So I moved to gradient boosting. After applying hyperparameter tuning on gradient boosting, I achieved only 91.5% accuracy on at max using tree structure Poisson estimator. Uh, in light gradient boosting, also tree structure Poisson estimator gives more accuracy, that is 91.5% accuracy. In gradient boosting method also, tree structure Poisson estimator gives more accuracy. In gradient boosting method, I used 4 hyperparameter tuning techniques. They are tree structure Poisson estimators, simulated annealing, grid search, and Bayesian optimization. For easy to understand, I visualize the hyperparameter tuning methods accuracy and base model accuracy. This diagram represents SVM as base model and what are the hyperparameter tuning algorithm that I have applied in SVM. This dark orange represents base model. In base model, that is SVM, I achieved only 75% accuracy. After that, I approach with several hyperparameter tuning algorithm. I achieved this much accuracy. At max, I achieved 86.53% accuracy in SVM model, and this is the graphical representation of comparison between base model and hyperparameter tuning accuracy. Here, the base model I used is LGB, that is light gradient boosting. In light gradient boosting, I achieved 85.71% as base model accuracy. After that, applying hyperparameter tuning, I achieved 91.5% accuracy at max. That is tree structured Parsons estimator. GBM, gradient boost method as base model. This is the graphical representation of a comparison of base model and hyperparameter tuning techniques accuracy. In base model, that is GBM, I got 83.3% accuracy. After that, I applied four different hyperparameter tuning on GBM, that is tree structured Parsons estimator, simulated annealing, Bayesian optimization, grid search. In grid search only, I achieved 91.5% accuracy. On my work, I unable to achieve that more than 93% accuracy. But my teammate is achieved 98% accuracy using linear discriminant analysis. Conclusion: in my work, tree structure Parsons estimators on LGB and GBM outperform other implemented model with an impressive accuracy of 91.5% accuracy. That is making it the top performer among the compared models. Thank you.